So when we talk about troubleshooting topologies, we really need to understand the topology and the technology. So let's go through each of these. We talked about the bus topology, and we talked about the fact that the bus topology works from that carrier sense multiple access with collision detection technology. And the signal goes through the bus, goes through the cable. And when the signal goes into the cable, it goes both ways. It goes down to the cable, it's electricity. Now when it gets to the end of the cable, if it's not terminated, it'll bounce back. If we don't have both of the ends terminated, then we're not going to have any communication in that segment. So what ends up happening is if we have a break in the cable, that will take down that segment, because the break in the cable will cause no communication, or it'll cause the effect of no communication, because in effect what we'll have are two networks, both of which have one end that doesn't have a terminator on it. So a break in a cable on a bus will cause a problem, will cause communication to fail in the entire segment that bus represents. And as we said, this isn't used very often anymore, but you should know this for the test. Now on the other hand, one single computer failure in a bus probably isn't going to cause any problem at all, because they use what are called T-connectors, and each computer just takes its signal off of the bus. Now if I disconnect a computer from the bus, that's okay as long as I leave the T-connector in the line. In other words, if I disconnect the T-connector from the computer, and the T-connector is still keeping the bus connected, then everything's fine. But if I disconnect any part of the T-connector, in other words, I pull the bus apart, well, then the terminator, then what I've done effectively is put a break in the cable. If I disconnect one of the pieces that causes that whole bus to be connected, then that won't only affect the computer that I did that on, it'll affect the entire segment. So it is possible to take a computer on and off of a bus, but you have to keep the T-connector in place. Some companies take when they used to use the buses, they would, when they installed the computers, they'd put a few extra T-connectors in line. And that way they could put another computer on the T-connector and not have to affect the bus and affect the communications in the entire bus. So you should know that just for the test. You're not likely to run into that in real life, but just know the aspects of that topology and technology. Another topology, the most prevalent topology, is the star. You should know that with the star we have a central component. So one computer failure won't matter because we've got a central hub, and every single computer has its own connection to that hub. So one computer failure won't matter, one cable failure won't matter as far as the entire segment is concerned. In other words, it won't affect the other clients that are in the star configuration. Now, if the hub fails, then that affects the entire configuration. So a lot of organizations have spare hubs, maybe use an upgraded hub. Some have, when I say hub, they might actually use a switch. So there are different ways to have some fault tolerance on that, because that's really the single point of failure, is that central point. Then we have what we call the mesh topology. And the mesh topology, as you'll remember, a full mesh topology is when all of the computers are connected to all of the other computers. And typically you're not going to see it in computers, you're going to see it more with networks. But a mesh topology, I guess the thing about troubleshooting a mesh topology is that it is extremely easy to do as long as you know what you're doing. And the reason I say it's extremely easy to do is because you still have so many different options. Even if you have a break in one cable, you still have the capability to have connectivity to other, to the computers through other cables. So sometimes the situation of troubleshooting, you can't troubleshoot a problem because of the problem. Well, with a mesh, you don't have that problem because you've got redundant capability which allows you to troubleshoot the problem. But you really need to know how the mesh is connected so that you know how to troubleshoot it. So the thing to understand about mesh for the test in regards to troubleshooting is really it's easier to troubleshoot a mesh, and you don't have to do it initially. You don't have to do it immediately because that's the whole idea, is you got the fault tolerance built in. But you need to have some way of knowing that there is a problem with one of those cables or one of those connections, and then you can troubleshoot that because you've got the other connections that you can use to troubleshoot it. And then finally, the ring topology. And as you know, the ring topology is IBM. IBM has token ring. Then we had the FDI topology, the fiber distributed data interface. So there are two different kinds of ring topologies. And ring topologies pretty much troubleshoot themselves. They're sending out signals around the ring all the time just to make sure that everything is in place, and they'll let you know if there's a break, and they can even identify where the break is in the ring. You should know that the ring is important. It's important that the ring stays in place because it can affect more than one computer. Since the token is going round and round and round the ring, if the ring doesn't get fixed pretty quick, then nobody gets the token. So that's the most important thing, especially with the token passing method, is that the ring has to be in place in order for the network to work. So those are the kind of things that you need to know in regards to troubleshooting topologies. So hopefully we learned something about troubleshooting in this chapter. But in regards to the entire training, we need to know, we need to kind of put it all together as to, what do we do now that we have this information, now that we know more about how networks operate. Then if we're troubleshooting a system, what do we do? What are the steps that we need to know about? And you need to know about this both for real life as well as for the test. There's a lot of different troubleshooting methodologies. You read different books, magazines. You'll see that many people have different ideas about the steps involved in troubleshooting. They'll come up with letters to remember them and whatnot. But what we're going to do is we're going to focus on the ones that are specifically set as the objectives on the CompTIA website for the 2005 objectives for the test. So that's next.